So coming to Bayesian classification, why we have to go for this? So let us see what actually this method is. These are the properties of Bayesian classification. So coming to this, the first parameter is it's a type of a statistical classifier. So what actually this statistical classifier does here? It performs probabilistic prediction. So we go for how is it we predict the future data using the method of probability. So it predicts classes membership probability. So based on the how is the number of class we are going to derive, what number of classes. So that is all done with the probability prediction. That is the main concept. Second one is here the foundation is based on Bayes theorem. There is already a theorem called Bayes theorem. With the help of that, we are continuing with the classification. So performance, it is a simple Bayesian classifier called Navy Bayesian classifier. So here it has a comparable performance with decision tree and selected neural network classifiers. So we can compare the result of this Navy Bayesian classifier with the decision tree induction. So here when we compare the performance of this statistical classifier called Bayesian classifier is used for the selected neural network classifier. So we cannot use for all the network types, only for neural networks. That to selected neural networks will be using this. So otherwise we usually go for decision tree induction because that is more advantageous in some of the cases compared to this. So particularly for the neural networks we go for Bayesian classification. So the next property is incremental. So each time we go for testing data, training data, all that, right? Just the concept is same. So each training example can incrementally increase or decrease the probability that a hypothesis is correct. Prior knowledge can be combined with the observed data. So here, how is the probability prediction we do? We observe some data in the database, right? So while doing this, we perform a theory called hypothesis. We write some theorem called Bayes theorem here. So you, with the help of that, so we come with a result of some theory, some thesis, what you call hypothesis means some research you would have done on the observed data. So that based on that, the probability theory of the observed data, we come to the conclusion that whether there is an increment in the number of class or decrement in the number of class. So that is how we try to analyze here. Coming to the next one, standard. So even when Bayesian methods are computationally intractable, they can provide a standard of optimal decision making against which other methods can be observed. So when you compare with other methods, next we also have rule-based classifier, k-nearest algorithm and decision tree, all that. So this is one standard method where we go for where it performs, where it gives the result of for Bayes theorem for the probability as probability of B is with respect to A is defined as algebraic sum of probability of B by AI. A is for attribute, one of the attribute, you can take B is another attribute, into P of AI, where I lies from 1 to m. So with this concept, we have derived the equation as Bayes theorem, the final equation for the probability of H by X. H is for hypothesis. What the observation you do with respect to X. H by X is what? Observation, some theory, some result you get with respect to X. What is X? X is some sample data. So let X be a data sample. So which I will give some name for this class label. So before it was unknown. So now I am deriving some classes with some label, right? So P of H by X is defined as, so H with respect to X is defined as P of X by H into P of H divided by P of X. Correct? So the same thing is written in the RSS. So let us understand what is P of H, what is P of X, and what is P of X by H. With the concept of this is just written, not necessary to derive here. Fine. Coming to the next step here, you understood what is X. X is a data sample where the class label is unknown, right? So here H is the hypothesis that X belongs to class C. So whatever the observation we do on X, so on that we write a term called hypothesis here that is done with respect to the class C, right? So that you will understand with an example. So classification is to determine P of H by X. I need to determine the result for P of H by X. What is that you are determining? What is this P of H by X called? It is called as posteriori probability. Two types of probability you can derive. One is prior probability, one is post probability. So the post probability is nothing but the probability that the hypothesis holds given in the observed sample P of H. I mean sample X. That means you are going to find h with respect to x here. Whenever I say p of x by h, that time I am going to find x with respect to h. That's all. So probability of h by x one time, probability of x by h one time, where x is the sample data and h is a hypothesis with respect to x that belongs to C. So what is h then? P of h then? It is prior probability. Understood, no? So example h I can take in the given example, you can take x as the number of customers who buy the computer. So now, so what these three terms? What P of x by h to be calculated, then P of h, then P of x, then you will be able to find the answer for P of h by x. Correct, no? So what is P of x? Probability that the sample data is observed. X is what? Given sample data. So probability that the sample data is observed is taken as P of x, and P of h by x is what? It is post probability that is taken by defining P of h with respect to x. Same way P of x by h is what? Probability of x with respect to h. The probability of observing the sample is given that the hypothesis holds. See here, whereas in P of h by x, how is that you write the definition here? P of h by x is probability that the hypothesis holds given the observed data sample x. Same thing here. In place of h, I am using x here.